Hello everyone! In a recent video, I provided an introduction to using the Twitter API with the Python package called tweetpy. In that video, we were able to make a request for user information given a username. One of the pieces of information that we received was the unique Twitter user ID for the account, for the user. We're going to use that in this video. If you don't already have one that you can use and you're interested in how we got that, I encourage you to watch that recent video. We're going to use that ID as part of a larger data science project demo. This demo is going to live in the cloud using GCP or Google Cloud Platform. I'd like to first sketch out what the demo is going to look like, the different parts of it, and that'll be our game plan for going through and building out this demo. So first, at the top, we'll have the Twitter API. We are going to have a Google Cloud function that is going to run periodically and fetch recent tweets from the Twitter API. This cloud function will be triggered via a scheduled job on Google Cloud Platform Cloud Scheduler. We can set how often we want this cloud scheduler to go off. For this demo, we'll do 24 hours. That means that our cloud function will run every 24 hours and fetch the most recent tweets. We'll want the most recent tweets since the last time we fetched tweets, so that'll be 24 hours worth of tweets as well. Now, ideally, we'd want to do something with these tweets. We'd want to store them somewhere that's persistent so that we can have some sort of script or service that runs later and is able to access all of the tweets and do some analysis or prediction with them. So the last thing we'll do is have our cloud function insert these tweets as rows in a BigQuery table. BigQuery is another GCP service that stores really big tables. There's other services that BigQuery provides, like some machine learning and analysis, but it can just be a storage service. From there, you can connect with other services to do your analysis and prediction. So what we're going to do first is go over the code to do this fetching, and then we'll talk about cloud functions. We'll write a cloud function for this fetching code, and we'll move it to the cloud with GCP. And then, once we test and make sure that it works, we'll set up a cloud scheduler job that runs every 24 hours to trigger a function. We'll set it so that we can test to make sure that it works. And then finally, we'll do this last part here where we add the functionality to our cloud function to insert our tweets as rows in a BigQuery table. Hopefully that provides a nice overview of the major services and all of the parts of this demo that we're about to do. Let's switch over to the code and take a look at how we can fetch the most recent 24 hours of tweets from an account. I have code here in a main.py file that opens a file called twitterkeys.json to load up a bearer token that's used to create a tweetpy client that's authenticated with my Twitter developer account's project app in order to make requests to the API. We covered how to do this in a previous video. I recommend you check it out if you want to follow along. You will need your own bearer token. Also in that video, we were able to get the unique user ID for an account. The account was for the Gonzaga University men's basketball team user. The current handle on Twitter for this account is ZagMBB, but note that this can change. This, however, will stay the same unless they make a new account, in which case there'd be a new user ID for that account. So what I want to do is write code to fetch the most recent tweets for this user, where we look at a start time that's 24 hours from right now. So the most recent 24 hours worth of tweets. So that's what this code right here does. It figures out what the time is right now using Universal Coordinated Time, UTC, and then it subtracts 24 hours from right now to get the start time, which we want to use in order to make our request for all the tweets from now back to the start time. I format this in the format that the Twitter API expects, and then I call this handy function, passing in our TweetPy client that's authenticated with our bearer token, our user ID, and our start time. This function here is pretty short. I'll show you the documentation for this function. Get users tweets right here returns tweets composed by a single user specified by the requested user ID. By default, the most recent 10 tweets are returned per request. Using pagination, the most recent 3,200 tweets can be retrieved. So this description right here is from the Twitter API documentation. TweetPy's get user tweets is a wrapper function for the user's ID tweets get endpoint. So the required parameter is the ID. We already have that. Here are some other optional parameters. End time. So if end time is omitted, then this will be essentially right now, the most recent time. I'm going to keep scrolling down to start time. Okay, if start time is omitted, then this is going to be the most recent number of tweets, which defaults to 10. We are going to specify a start time. So here's the format that the start time needs to be specified in. I've already written the code to do this. We can also provide some additional tweet fields that we want about each tweet. And that's what I've done here. So I call client.getUsersTweets, passing in the ID, the tweet fields. I want what time the tweet was created at, in addition to the base information, which includes, for example, the tweet text, the tweet author, etc. And here's where I pass in that start time. This code right here parses the response data and creates a list of dictionaries. I call the list rows because these are going to be rows in our BigQuery table. So let's run this. And unfortunately, since we're in the off season of basketball right now, we actually don't get any tweets in the most recent 24 hours for this Gonzaga University men's basketball team account. So let me just change this to 30 days so that you can see what results would look like from running this code. Okay, here are the tweets in the most recent 30 days from this account. Let's take a look at one of them. I'll highlight it in its entirety right here. So this is the first one in the list. So there's a tweet ID, uniquely identifies the tweet. There's an author ID. You can see this matches the Zeg MBB username user ID right here. And then created at, that was the additional information that we wanted. So May 17th, 2023 at 6:44 UTC time. Here's the text, Windy City Zags, and a URL. And then this is the start of the next tweet. So these are the tweets that we want to be able to fetch every 24 hours. Now, like I said, because we're in the off season of basketball right now, there's not many tweets coming out of this account. So just for testing purposes, I'm going to set mine to days is assigned 30. But I'll put a comment right here that we should change this back to 24 hours to stick with our original plan. Okay, great. So this is the code that we can test locally. It looks like it's working. We now want to think about how can we migrate this code to Google Cloud Functions. So let's head over to the Google Cloud Console and take a look at the Cloud Functions service. Go to console.cloud.google.com, sign in, make a project if you don't already have one you can use. And then what we're going to do is we're going to search for Cloud Functions. This is the service that we are going to use to set up our Cloud Function code to run in the cloud. So it says, welcome to Cloud Functions. Cloud Functions is a lightweight, event-based, asynchronous compute solution that allows you to create small, single-purpose functions that respond to cloud events without the need to manage a server or a runtime environment. Perfect. That's what we want. We've got some code that we want to run every 24 hours. It's pretty short code, and we don't need to set up an entire, say, VM for its runtime environment. Let's hit Create Function. It's going to check to make sure that you have all of the required APIs enabled. Looks like with this fresh project I just created, 3 additional ones need to be enabled. That's fine. I'll hit Enable. This will take a little bit of time. Once those APIs are enabled, we're brought to the Create Function configuration page. We'll be leaving almost all of the defaults as is. If you'd like, you can give your function a descriptive name. For example, I'll call mine tweet fetcher function. I'm going to keep scrolling through, leaving all of the defaults, but if you're familiar with Cloud Functions and you'd like to change some of these, go for it. Hit Save. Expand runtime build connections and security settings. Under runtime environment variables, we are going to hit Add Variable, and we are going to put our Twitter API bearer token into our runtime environment as a variable. So let's call this bearer_token. And go ahead and paste your Twitter API bearer token here. This way we're not hard coding it into our Python code, but we're not needing to rely on our Twitter keys.json file right here. We'll be able to just grab it from environment variables. I'm now going to hit Next, and this is going to bring us to the second page of Create Function number 2 code. We're going to change our runtime environment to Python 3.9 or whatever Python version you were using to test locally. Under source code, leave it as inline editor. You'll see that there are 2 files that we will need to modify. The first is main.py. If you click on main.py, you see that there's an entry point set to hello world, and then in the code there's a function called hello world. So this is essentially saying what's the main entry point for this Cloud Function in this main.py file that we can edit in the browser. So we have to adhere to the interface that GCP puts forth for using Cloud Functions, which includes having a function with a name that matches entry point and has a parameter request. So the type of this parameter is a Flask.request object reference. If you're not familiar with Flask, it's a lightweight web framework. You don't need to be any more familiar with it than that in order to continue with this demo. We will have to write our own function that adheres to this signature. There's some documentation you can read here. You can take a look at the example. Essentially, if the GET request to our function, our HTTP GET request, has a payload, a body, we can grab it from this request object. Ours won't have any. There's no arguments coming in to our Cloud Function that goes and fetches the 24 hours worth of tweets. We're going to hard code our user ID. We could, as an expansion, we could get that user ID from the client that's making the HTTP request, but keeping it simple, we're not going to do that. So we essentially will be able to ignore this request object. We will do all of our Twitter API client object creation, our request, our parsing into rows here, and then we'll need to return some sort of response, which If all goes well, we'll just be success status code 200. So let's go back to our editor here and let's write a function called entry point. So this will be our actual cloud function here. Recall that this request object will be a flask.request object that we can ignore for now. Because there won't be any data in the GET request body. All right, so what do we want our cloud function to do? Well, essentially we want it to do everything we did down here in main. So I'm gonna just cut this, and so we can still test this locally, we'll just call entry point. We do have to make a few changes. For example, our bearer token is not going to come from a file anymore. It's going to come from an environment variable. So os.environ to access the environment variables, .get, and then make sure you use the same name here as you did on the previous page in GCP create function when we made our environment variable. We will need to import the OS library. And now we should be able to create our TweetPy client using our bearer token we get from our environment variable. This looks good, this looks good, this looks good, this looks good, and this looks good. We'll still print out the tweet rows. Remember, just for testing purposes, we're setting this to days is assigned 30 because at this time there weren't any tweets from this account in the most recent 24 hours. We'll be able to go look in the logs to see this output and make sure that it matches what we could get locally. Now I'm going to put a to-do in here, which is going to be insert tweet rows to a BigQuery table. We're not going to do that right now, but I want to make a note that this is where we would do this. And then finally, let's return success as our response in status code 200. All right, we'd be able to test this locally if we set up this environment variable. I do not have this environment variable set up right now, so I'm not going to test this locally, but I am ready to copy this whole main.py into my inline editor in the cloud and test it out. Note that we've got a little warning here saying, hey, there's no hello world function in this code. That's true. I need to change this to entry point. Now I'm going to go to my requirements.txt, and this is where I need to specify all of the Python packages that need to be pip installed in order for my main.py to run. So if we look, OS is a standard package, JSON is a standard package, datetime is a standard package, but pandas and TweetPy are not standard Python packages. So I will need to put these in my requirements.txt. So we'll do pandas, TweetPy, and I don't need this right now, but I will later, so I'm going to add it now, Google-Cloud-BigQuery. Everything looks good. Let's hit deploy. This will take some time to deploy. It looks like our cloud function deployed successfully. We see a green check mark and it says the function is active. Let's head over to this testing tab and try it out. So on the left side of this tab, we see configure triggering event, and this is where we can configure the body of the request. Now recall that the way we wrote our function, we're ignoring the request and not expecting there to be any data in the payload. So we're just going to leave this blank, empty, and we're going to scroll down a little bit here till we see test the function. It says running, and then on the right side it'll show you the curl command that's being executed to test the function. I'm going to scroll down, and we should be able to see the output. So it says output complete. Here's the success. This is the string that we sent back. And it's also going to grab the logs where we should be able to see the output of our print statement. So let's expand this here. And there are our tweets right there, the most recent 30 days of tweets. You can also see all of the logs, not just the ones associated with this test case, by going to the Logs tab here. So it looks like our Cloud function deployed successfully. We were able to test it. That's all we'll do for this video, but stay tuned for the next video where we'll do our next 2 parts of our project example. We'll head over to Cloud Scheduler Service and schedule this function to run every 24 hours. And then we'll head over to BigQuery, make a data set, make a table, and see how we can insert our tweets as rows into this table from our Cloud function. See you there. Thanks for watching.